All right, good afternoon.
Good afternoon. Good afternoon.
All right. Hope everybody's doing well. Hope you survived the snow. My camera is frozen-ish. Striking poses. All right, I don't know what's going on with my camera. Um, all right, let's start with any questions on. I'm going to talk about PA1A. I'm going to talk about PA1B and talk about ODPs, try-catch blocks, um, some other stuff, and I am going to talk about getters and setters and private vars towards the end of class, and that'll be your next ODP. So, any questions up front before we jump in?
Do you have a question about, since I moved to sections, I don't know if my ODP 300, I need to resubmit it or not.
So ODPs don't pay attention to sections, so that's fine. After the ODPs close, I need to go in and manually push the grades over to Canvas. And I usually do that once a week, but we only had one ODP last week, so I probably won't get to that till this weekend. We'll have two ODPs this week, and I'll push all three of those in over the weekend. But as long as Canvas tells you, as long as the ODP assess tells you that you got 10 out of 10, you should be good to go, and that's recorded elsewhere. So after I get the grades loaded, if you ever see a discrepancy, just let me know, and it's probably just a glitch.
Thank you.
Mm-hmm.
What day are you gonna post the second assignment?
Probably next week.
Okay.
So probably on Monday, or sometime over the weekend.
Cool.
And you'll have 2 weeks for the second assignment, so it won't be the breakneck pace of PA1.
We building a tree?
You want me to ruin the surprise?
Sorry.
I don't know exactly what I'm going to do for PA2. I think it's going to be a combination of linked lists and other stuff. So something where you're using multiple data structures together. And eventually in a later assignment, we're going to build up a decision tree and use that to code up a game. Alright, let me take one shot at fixing this camera here. Do the wall cam. And let's see if that works. 0 frames per second, that's exciting. I think I have a Minecraft server running in the background, so that might be killing my camera.
Yeah, if it's modded, then it's a resource hog.
Yeah, even unmodded, I think it's... Alright, we'll just go with this one. It's not great, but it's better than nothing. Alright, well let's go ahead and talk about PA1A first. So overall impression, really fantastic job with this assignment. this was an assignment I haven't given before, and it's a meant to be a bridge between C and Java, basically. And it looks like everybody was able to cross that bridge successfully and get their old PA2 from 222 recoded in Java. And it's not making classes and working with objects the way we normally do in Java, but it was a chance to learn how to compile and run and the basic syntax differences and so on and so forth. And it looks like everybody got that to work, which was fantastic. So I posted a lot of feedback in some cases, and not all of my feedback translated to point loss. So if you got like a 95 out of 100, you might still have 3 or 4 paragraphs of comments. It's probably worth reading those. So some of the things that people ran into. One was printing from the methods that you were creating for the stack and the queue. For example, the pop stack. The goal of pop stack is to just remove the top of the stack and return it as an integer. The caller, the main program, can choose what they want to do with that. They might choose to print it. They might choose to do nothing at all with it. Right? It's really up to the caller. But if your pop method also prints to standard out, your pop method's probably not terribly useful in general, because not every time that you pop do you want to print the output, the pop number, to standard out, right? That's up to the caller. And so we want this separation between caller and data type, right? Your main method, that's the thing that's calling the methods that comprise your stack or your queue. And if you want to pop something from the stack, you just want to call a pop method. You want it to pop. It's going to return it to you as an integer. That's all it should do, right? For example, when you call the square root function in a C program, if that automatically always printed the square root to your screen, that would not be a useful function, right? When you were trying to calculate a quadratic formula to find the root of an equation, there'd be all these random numbers popping up on your display. That would be frustrating. So the square root function does not print the square root, it returns the square root. The pop function does not print the number that's popped, it just returns it. So we want to be really careful about doing exactly what these methods are supposed to do and nothing else, to keep them as general purpose, as usable as possible. So that was one issue, was a few people printing things like inside pop and so on and so forth. As far as stack underflows or removing from an empty queue, I said that your methods did not have to handle that, and that I would not call your methods myself, in the case where the stack was empty or the queue was empty. But your main program needs to manage that. You have isEmpty methods, and any time that you're writing code to work with, say, your stack package, if you're thinking about popping the stack, see if the stack's empty first. Right? Unless you know there's something on there, you should not call the stack pop method. And so in your main program, it checks to see if it's empty, and if it is, it prints a message and says it's empty. Otherwise, it calls pop and prints the value. So you don't want to be generating exceptions from your program, except, the one exception we said you were allowed in PA1A, which is when you put in an illegal integer, it's allowed to throw an exception and exit. Now we're going to take care of that in PA1B. Those were the main issues that seemed to pop up multiple times. A few minor issues here and there that I think will take care of themselves in PA1B. But take a look at the feedback. Ask me if you have any questions about the comments I made or about anything else. But I think everybody did a great job on PA1A. And hopefully you're being successful in translating that to 1B. A bunch of people have turned that in already, and so I think that's working out well. Any lingering issues or questions on 1A? All right. Let's talk about the ODP next, because then we'll go ahead and we'll talk about 1B, and that'll take us into try-catch blocks. So let's talk about the next one-day program.
I actually do have one question about, I guess it's 1A and B kind of. So the linked list, I had put the angle brackets integer. So how does the linked list know what type of data, or is it just not strict data type for the contents of the list?
So when you do that type, that parameter in angle brackets, that's what tells it. So if you declare linked list angle bracket integer stack, you're saying this is going to be a linked list that will hold integers.
Yeah.
Right, which I believe you did, because I think everybody did this.
I think I did.
So if you say angle bracket string, then you're declaring a linked list of strings. And you need to use this two places. You need to use it in the declaration, right, which is saying what type of thing stack is, and you also need to use it in the construction. So when you say new linked list, you've got to specify it there, integer.
Okay.
And if you don't, you get a warning from the compilation, and definitely in Java, you need to pay attention to warnings. Even though they compile, you need to treat them as errors and make sure that you get rid of those.
Yeah, that I misinterpreted your comment here, so
Okay.
I get it.
All right, cool.
Thanks.
Yeah.
I've seen those angle brackets before in Java. Are those just for data types specifically, or
They're generics.
Those are for something called generics, yeah.
Yeah.
Which we'll talk about probably next week. It's part of what lends itself to code reuse. So you can write a batch of code that works for integers, and maybe the exact same code works for strings, except everywhere that you say integer, you have to say string. And instead of writing, integer linked list is one class, and string linked list is another class, and character linked list is a third class, you make one class and you say, hey, but when you use this class, specify a parameter. And then inside the code that makes up that class, you can use that parameter to do things like declare other objects and so on. And so like a hash map, you specify two parameters, the type of thing that makes up the keys and the type of thing that makes up the values. And so this is a general mechanism called a generic.
Can I ask a question about that, not to get too far ahead?
Sure.
Is it an oversimplification to just think of it as a type parameter? Because that's how I've been using them.
That's really all it is. I mean, for the most part, it's when you write your code, you'll put angle bracket E typically, and then anywhere that you use E in your code, it will get filled in with whatever was put in here. So it's kind of like a macro expansion, and it lets you sort of write more generalized code.
I've used them for collections and delegates
Mm-hmm.
mostly. They're pretty useful for that.
Right, right. Cool. All right, good deal. So ODP 301. Let's take a look at the README. So 301, you're creating a class named myClass, and it's got a constructor, myClass, and the constructor takes an argument, which is an integer. So this is kind of like the rectangle class that we did. And the whole purpose of the myClass is to save this integer in a variable called x within the class. So after you construct myClass parentheses 17, if you made an object MC, which was that new myClass, you should be able to access mc.x and get a hold of that 17. Or change the value mc.x equals 23, for example, and see that 23 when you access it. So the constructor does one thing. It takes this argument, it saves it in a public field named X within my class. And that's it. That's the whole class. So you wanna create this class and maybe test it out, with a main program like this, and then assess it. So make sure it's in a file called myclass.java. Compile it. Make sure it compiles. Maybe make a main method like this. Compile this and run it. Make sure it prints out 17, then it prints out 23. And then when you're ready to assess, use this as your assess command. So assess, this is the test bed program, this is your source file, and use the G command to go for 10 out of 10. And so this is a subset of what we did with rectangles, basically, where we could construct a rectangle, we could specify a height and a width, and then later on we could come in and we could say, set the height equal to this, or show me what the width is, and so on and so forth. And we're doing this because in tomorrow's ODP, tomorrow and Thursday, ODP 302, we're going to change this to where this variable x is private within my class. And so we'll be able to give x a value in the constructor, but we won't be able to access it like this or modify it like this. And that's going to introduce us to something called accessors and mutators, which are ways to read and write private fields inside objects in a controlled way. And so we'll talk about accessors and mutators probably at the end of class today. Those are also called setters and getters.
Mutators are called setters and getters?
A mutator is the same thing as a setter, and an accessor is the same thing as a getter. It just doesn't alliterate as nicely as getter and setter.
Gotcha.
Yeah. All right, so questions on 301?
So just to make sure we're making it so that we're inputting a number, it's saving that number, and then we're just saving it, and that's it?
Yeah.
Cool, thanks.
Yep. Alright, cool. We will call that done. Let's talk about PA1B. And so we introduced this last class. Well, let's go through the gorier details. So it's the same behavior as what you had in 1A, right? The same stack and queue program for interacting with those structures, but you're creating a pair of classes, myStack and myQueue, and each of those has a linked list inside it, and declare that linked list as a class, as a variable in the class. In other words, if you do class myStack, you want a linked list inside here to represent the stack, so you could do something like linked list angle bracket integer, and I don't know, you can call it whatever you want. And this represents the actual stack that's stored inside this class, right? And then make a constructor. Public myStack, and inside here do your construction where you set stack equal to new linked list angle bracket integer. But I've seen a few people who declare their stack object inside the constructor. Well, anything you declare inside a constructor is local to that constructor. So once you leave the constructor, the thing that you made is gone. So when we're making a class, if there's fields, if there's objects in this class that we want access to, that we want to have persist, we declare them as basically globals inside the class, right? Declare them outside of the individual methods, and now they're part of the object, and they persist as long as the object persists.
You know, it's funny, I did that when I was writing the program, and I declared it inside my constructor.
Mm-hmm.
And for the life of me, I was like, God, why is this not working?
Yeah, you get all these like undefined symbols.
Oh, so yeah, and then I looked at it closer and I go, oh, I never declared outside.
Right. Yeah, it's a subtle thing.
Wasted about an hour of my time for sure.
Oh well, not wasted though, because
That's right.
it's ingrained now.
This, like, if you want to declare a variable inside the constructor, but you use the this keyword, and you use the this keyword to make it part of the class scope.
This would refer to something defined like this, declared like this. So inside here, if you had another variable named stack, that would be local to the constructor. If you wanted to get to this stack, you can say this dot stack. But I'm avoiding talking about the keyword this for as long as possible, because it becomes a Dr. Seuss exercise.
I was just wondering, because in Python you're allowed to declare the constructor as say self,
Mm-hmm.
and then dot a variable, declare it that way. So
Right.
You don't have to do it in the global class scope.
Mm-hmm.
I've never tried that in C#.
Okay.
I was curious.
Yeah. There's a few cases where we need to use the this keyword, like when we want to pass, a reference to ourselves to another method or something. But we'll hold off on it for a little while.
Understood.
But you're welcome to use it if you like.
Yeah, I did that on the ODP. It actually worked.
Okay, cool. Yeah, it's not bad to use it. It's just it gets confusing, and you talk about, well, this has to get passed to this, but when you get this, then it's this other this.
Just out of curiosity, so when you're calling this, from my understanding, you're referencing just that object that's being constructed.
This is the ego, basically. It's your sense of self. It's the way that an object can refer to itself.
Okay, that's what I thought. Okay.
Yeah. And we know what that self-awareness leads to, so.
Terminator, right?
Yeah, right? All right, so you got two classes you're writing, myStack and myQ. And then your main method is going to construct the stack like this. Instead of saying, stack is a new linked list, it's going to be a new myStack, and your queue is going to be a new myQ. And then pretty much, the behavior of your main program is the same, except for this deal right here. And this is the big change, right? So instead of one stack push function that you pass a stack and a number to, you access the push function for this particular stack as stack.push. And you just give it a number. So this is just sort of rearranging your code, restructuring it, using it in a different way. But the code itself is fundamentally the same, right? The actual Java statements that you write inside the push and the pop and so on, those don't really change. It's just how you sort of organize them inside the class. Alright, and then submission as a tar file. So, there's one addition in here, this important addition, which is you should not throw an exception if the person types an illegal integer.
Gee, can I ask a quick question?
Yeah.
Regarding the macro program. Are you wanting comment blocks on this one in front of the methods?
I want comment blocks everywhere.
I comment through the code to say exactly what it's doing, but do you want actual blocks to explain what the actual functions are doing?
I would throw in at least a one-liner. And if there's anything interesting going on, throw in more than one line. But yeah, so this is a general remark I should make. So I saw a lot of good commenting in some submissions. I saw some submissions with 0 comments, nothing, no double slash or slash star anywhere in sight. You really got to get in these habits, right? Because you might spend 3 weeks on an assignment at a university and turn it in and get a 0 because you didn't put your name in it, right? and the teacher might just have this rule about, no name, no grade. Get in these good habits. Put your name in your code. This is your creative work. This is, something you have authored and written. Put your name in it. And get in the habit of putting in, a little preamble about what it does. Put a sentence on top of each function or method or class. And then, yeah, definitely document the code as you're going through it. If your whole, is empty method is just a call to the linked list is empty, you don't need to write an essay about that, right? You could, but you don't need to. But, just a little one-line blurb, return true if stack is empty. That's plenty. And it just saves you, if you go back to your code, from having to go in and look at the code and reverse engineer it. And as the assignments get more aggressive, the commenting will become more critical.
It's also really useful for other people to know what you're doing, and I don't know how Eclipse works, but I'm sure it does something similar. When you comment the top of your functions, if you start trying to type the name of that function and use it somewhere else, it'll give you a little blurb of what the documentation is.
Mm-hmm.
At least I see that in a lot of editors.
Right.
Which is really helpful, because then you may not need to look at the documentation. You just have a little short blurb there, what it does and how it works.
Yeah, so as you move into IDEs, and especially a lot of teamwork and working on very large projects, these things become more than just kind of like, oh, this would be kind of nice. They become pretty critical. So like a decent IDE, when you're writing Java code, if you begin to type the name of a method, the editor will know what kind of object you're using to invoke this method. And if it knows what types of arguments it has, it may throw up, the rest of the method name, parentheses with types and names of placeholders for the arguments. And, there's your documentation. What's the first argument? What's the second argument? And so on. And this is all supported by standardized documentation and unified style habits and so on and so forth. And chances are, when you're working in teams, you're going to be required to adhere to, some coding standard, some style guide. It may change from project to project, right? But there will be something. And so just getting in the habit of, being able to follow some kind of style guide, for now just your own, will make that transition more successful.
And can you still use the / star in Java? Is
Yeah.
that pretty much universal?
Yep.
Oh, okay.
So Java, you can make a comment like that, or you can do a / star and then put in a bunch of blocks and then do a */.
That would have been nice to know last term in Java, because I just kept doing slashes for every line I had.
Mm-hmm. So related to this, and the / star is javadoc. And so when you look at documentation, like the Java documentation for the string class, and it's got this format to it, you can comment your Java code in a way that a utility called javadoc will automatically generate these kinds of HTML pages for you from your documentation in the code itself. And so, for example, when you begin a method, if you put a comment block in the beginning, but you started with a / and 2 stars, the javadoc utility will notice that, and it will look at this comment for certain keywords. And it'll find keywords like, args, colon, and a description of the arguments, or return, colon, and a description of the return value. And you can run this utility on your source code and have it produce HTML pages like this. And the result is you get, this beautiful standardized looking documentation that everybody is used to looking at and used to working with, and it's all hyperlinked, and it describes, the code that you've written. And that's really useful. right? And so some of the things I've been having you do throughout this sequence, putting comments before functions, putting comments in the beginning of your program, and so on, will move pretty painlessly over to using javadoc. And then you get, you know, sort of truly self-documenting code with the help of one utility that takes your code and turns it into this kind of thing. And so that's pretty useful, and we'll play with that in a few weeks. All right, so parsing integers. So we know that we can use this integer.parseInt. It takes a string and it returns an integer. And if you put in a string like, you know, character 2 followed by character 3, it'll give you back the integer 23. And if you put in something that's not an integer, like hello, it throws up. It gives you an exception. And so for PA1A, we said that was fine. Go ahead and let that happen. PA1B, we want to catch those exceptions and handle them gracefully. So we need to talk about how to catch exceptions. And in C, right, what we would do is you would use the scanf tool, the scanf function, to convert from a string to an integer. And the return value from scanf would tell us whether or not we had an error. That's not how this works. All right, so if you look at the documentation for the integer class, and you look at the parseInt function, it says blah, 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 blah. At the bottom it says throws number format exception if the string does not contain a parsable integer. All right, so we need to talk a little about exceptions. Exceptions are unexpected conditions. They're when something occurs that wasn't, you know, expected to occur. And they're very similar to interrupts. So if you've done Engineering 270, we talk about interrupts, right? And an interrupt is your program's minding its business. It's in a loop. It's doing some counting or whatever. And all of a sudden, you know, someone taps it on the shoulder and it jumps to location 8 and starts doing something else. That's an interrupt. It's kind of what an exception is. Your program's going along. It's doing its thing. It reads a line. It calls parseInt. And all of a sudden, it's somewhere else. And where it is somewhere that it jumped to because it tried to parse a thing that wasn't parsable as an integer. So it's a software interrupt. And just like we can catch hardware interrupts by setting up an interrupt handler, we can catch software interrupts. And we can say, hey, when something weird happens, don't just go to your default code that, you know, prints out the big long error message and exits. Let's do something different. And so this is called handling or catching an exception. And in Java, there's a really easy mechanism we can use for catching exceptions. So the trick is, if we have a statement that we think might cause an exception, we put it inside what's called a try block. So this will be try catch blocks. So we can say try, and we can have, you know, some statement. And then we can say catch, and some other stuff. And the idea is if this thing fails, then we end up here. So we put some statement that might fail inside this try block, so try in a pair of curly brackets, and if this statement fails, the code will jump to a corresponding catch block, and this is where we go to catch the exception. And the catch statement needs something like an argument, something in parentheses. And usually what we put in here is the name of some exception and then the name of some object that's going to hold that exception for us. Alright, so if we execute some statement and it works fine, the catch block is ignored and we just come down here and continue executing. But if we try to do some statement and it fails, for example, we try to do integer.parseInt and the string is not parsable as an integer, we will jump down to this catch block. Thank you. And whatever exception caused us to jump down here will now be loaded into this object called E. All right, so let's do some code. I'll just leave the equal sign. Ugh. What did I do, man? Alright. Do our good old main class named main. Alright, so let's just ingest strings from standard in and parse them. So while we have another line, my internet connection is unstable. Okay, that's good. Alright, so let's convert this thing to an integer and let's just print it out. Alright, and I'll do my import. All of this stuff gets a lot easier when you use IDEs, by the way. So if I wrote this in Eclipse, right, I would get a squiggly line underneath scanner, and if I hovered over it, it would say, you know, you need to import Java util scanner. Do you want to do that? And I just move down and click yes, and it would go ahead and add that import statement for me. And when I created this class, I could make a little checkbox that says go ahead and create a public static void main, and it would write this part of the main method for me, this whole line and the curly brackets and so on. So we're doing this by hand because we want to learn these things. We want to know how to do these things, and typing them in, repetition helps us learn those. But you know, if you're doing Java for a living, your boss doesn't want to pay you to write public static void main parentheses string bracket bracket arg close paren curly bracket 1,000 times a week, right? So you hit a checkbox and it does it for you. But for now, it's worth, you know, sticking to the command line and a simple editor and doing this the old-fashioned way. So let's see how we did. Pretty good. All right, let's run this. So I forgot to prompt the user, so that's kind of rude. So I'll put in 23. 23 times 2 is 46. I'll put in -10. That gives us -20. I'll put in hello, and it, spews on the screen an error message, a stack trace, and then it exits. How rude. So PA1B, we want to be a little more controlled. So we're going to do a try catch block. Let me put a prompt in here. So we'll say enter a number please, and at the bottom of the loop we'll say enter another number please. Alright, so now it's a little friendlier to us. Alright, so let's catch these errors. So I'm going to put a comment around convert to an int. This might cause an exception. So I'm going to say try. I'm going to put this in a try block. Alright, and my catch statement, I'm going to do something a little different. I'm going to look at my parseInt again, and I'm going to see exactly what the exception is that it can throw. So parseInt could cause this number format exception. And so I'm going to say catch a number format exception. I'll call it E. And I'll put a message in here which says alright, so what's the setup here? We're going to try to convert buffer to an integer. If it succeeds, the catch block is ignored. We'll come down here, we'll print out 2 times n equals n times 2, and so on and so forth. But if something goes wrong, if this throws a number format exception, the system will look for a catch block that expects a number format exception, and if it finds that, it will set E, which is an object of this type, equal to the exception that occurred, right? Which means it will let us analyze the exception, and then it will start executing the code in this catch block. And in this case, we're just going to print out, what the buffer is and say that's not a valid integer, please try again, and then we'll go back up to the top of the while loop and try again. Alright, this is not going to compile the way it's written because I've done something that's very common in this situation. I'm going to get this error about cannot find symbol n. And this is at line 21, which is right down here. And so why can't it find the symbol n? Why doesn't it know what n is here? Any ideas? Yeah, it's a question of scoping. So I defined n to be an integer, but I did it right here, which is inside these curly brackets. So once I leave this closing curly bracket, integer n does not exist. And in particular down here, I ask it to print out the value of n. It's like, what's n? I've never heard of that, right? Because I'm outside the scope where I declared it. And this happens all the time when you try to put try-catch blocks around something. Sometimes you have things declared that end up being declared inside the try-catch block. And it's a really, really simple fix. Just declare outside. So, I mean, I could do something like this. And I'm just making sure I declare it outside so that it's accessible outside the try block, including down here in particular. So now if I compile, it compiles fine. And when I run it, it says enter number please 23. That works fine. Enter number please, I say hello. And it says hello is not a valid integer. Please try again. I can say why. Why is not a valid integer? Question mark. Empty line. Cat walking on the keyboard. Right? And then you put in an integer and then everything's happy. Alright, it's making sense.
So far, so good.
Okay. Yeah, okay, so some good comments in chat about websites generated from comments that have tags in them, right? So that's like javadoc. Vim command extensions are available for most IDEs. True. So Eclipse, you can load in something called VWrapper, and it lets you use VI editing inside Eclipse instead of using Notepad style editing. So if you like VI, right, you can take it with you. And enough people like VI that most of the popular IDEs have plugins or extensions for them that let you do VI.
That's pretty cool.
That is, or some things like Arduino will let you use an external editor if you want. You just check a box and you can edit your files outside of the Arduino IDE, and then you can use VI to write your Arduino code, and it automatically gets loaded in, and you can compile it and upload it from the IDE as usual.
I'm a little confused about the catch number format exception and the E.
Okay, let's dig into that. Let's
Why
take a
is
look
that
at...
set up that way, and why does it make sense?
Yeah, let's take a look at what this is. So first of all, let's look at E. So you can almost think of this as like a function call. If an exception happens in here, it's kind of like it makes a function call to this thing. And this thing is expecting an argument of type number format exception, and we're calling that argument E. E could be anything we want. A number format exception is an actual object, right? It's a class, right? Which means E is an object of type number format exception. And it comes with a variety of methods, including, for example, get stack trace, get message, get cause, and so on and so forth. So let's just play around with this E. So let's print out the value of E. And we'll print it out inside angle brackets just so we can see where it starts and ends. So I'm just going to, inside the catch block, print a message saying, hey, I'm inside the catch block and this argument E is equal to, and let's see what exactly this thing looks like.
Is there an error stream in system, like out and in?
Yeah, there should be a system.error, ERR, I believe. So inside the catch block, E is equal to, and it's equal to all of this stuff. Java language number format exception. Well, that's the kind of exception that we just generated, right? Java language number format exception. But it also tells us for input string, quote, hello. So in this case, when this catch block is executed or called, if we like, the value of this parameter is the name of the exception, and it also contains a string that was trying to be parsed. And maybe we care about that, maybe we don't. But we have to have this present here anyway, even if we're not going to do anything with E. But we can get some useful information out of this. So for example, one of the methods we can call is print get stack trace. And so let's call e.getStackTrace and print out what that returns. Oh, didn't like that. Get stack trace. And it's a method, so we have to put parentheses at the end, otherwise it's just a field. So let's run this. And let's say hello. And it tells us stack trace was equal to this thing. And so it's telling us where this error occurred. And this is not a very interesting stack trace, but if you have a method that calls another method that calls another method that calls another method that eventually causes an exception, this stack trace will show you all of the calls that were made that led to that exception happening. Let me try print stack trace. All right, so there's a full stack trace. Print stack trace returns all of this. So at line 16 of main.java, a call was made to integer.parseInt. At line 615 of integer.java, a call was made to another method. And at line 580 of integer.java, a call was made to number format exception.java. And at line 65 of that, it threw an exception. And so we can see the call frames, right, the list of who called whom, from the original line of our program that called, that caused the problem down through everything else that was triggered because of that. So this is a stack trace. It's last in, first out. So the thing at the top of the stack was the last call that was made. The first call that was made was this one. That's the call that we made. That's line 16, which was up here when we said integer.parseInt. So the parts of the stack trace that are topical to your code are probably at the bottom of it, because that was earlier in the call chain. So you can get a stack dump for your stack program. Can you make your own exceptions, by the way? Yes, you should be able to. And you can throw an exception by using the throw keyword. And you can extend exceptions to create your own. You can do anything you want in Java, pretty much.
Is there like a base exception class?
There is. We're going to get to that in about 1 minute.
Gotcha.
All right. So is this making more sense? Right. So this is just a parameter. I could call this, Barney and Baby Bop, and it would just be a object that I could, print out or invoke methods from, and so on and so forth. And the object would be equal to the exception that caused us to come down to this catch block. And so it turns out we can have multiple catch statements.
Would we lose any points for just using a generic exception and not the specific integer exception?
Nope, that's totally fine with me. So if we want, we can have multiple catch blocks, and in each of these catch blocks we can name a different kind of exception. We could say this is where we get a arithmetic exception, this is where we get a divide by zero exception, this is where we get a generic exception. And when an exception occurs, the first block that matches the actual exception that occurred, that's the block that gets executed. And so there's a hierarchy of exceptions. And so parsing can throw a number format exception, but that's actually a more specific version of an illegal argument exception, which is a more specific version of a runtime exception, which is a more specific version of an exception. An exception is kind of the most general exception. Every exception is an exception. Many exceptions are runtime exceptions, but some are something else. Only very specific errors are number format exceptions. So if an array goes out of bounds, it will not, match a number format exception. And if I have a catch block that says number format exception, that will not fire if I have an array going out of bounds. But if I have a catch block that says exception, that will match any exception that occurs.
Because all exceptions inherit from the base exception class.
Exactly. So this is very specific. This is very general. So any exception that occurs in this try block will cause this catch block to fire. And most of the time, at least when I write code, I just use exception. Most code that I've looked at, it just uses exception. Unless you really think there might be, more than one possible exception that occurs, this works fine. And a lot of the time, you don't even care about this parameter, but you have to specify this part of the catch statement anyway. But a lot of times when exceptions occur, you're going to give up, you're going to exit the program, you just want to do it kind of gracefully. And it's really unappealing to a user to see something like this coming out of their program. I know, because I have a program I've written and it does this to me all the time, and it always kind of like feels like a kick in the gut. You'd like, something nicer, like, I'm sorry, Nick, I can't do that, So if you want details of the exception, though, it's available here. And again, this exception is just, it comes from another class, and you can get the message itself, or get the stack trace, and so on and so forth. And all of these you can read on. And this is kind of, a little bit of the shady underbelly of the system. So it's good stuff.
Also allows you to make hints.
Mm-hmm.
So if you run into some error, you can give your user some hints on what might be wrong.
Right, right. And you can choose to keep running and try to do something different, or you can just give up, or it's up to you. All right, so there's one other piece of this. So this is a finally block. Finally blocks, not finally clocks. So you can have a try block, you can have one or more catch blocks, but you can also have a block that says finally. And whatever is in here gets executed at the end of either the successful try block or the catch block that you executed. And it's a way to sort of do something at the end of all of this, whether the statement in the try block succeeded or failed. And so let me make a new version of this. And let me clean this up a little bit. Alright, so I've got a try statement, which is where I'm parsing the end. I've got a catch that will catch any kind of exception. Let me get rid of this. And then I've got a finally block, which will just print out a message saying, hey, I'm inside the finally block. So if I put in a number like 23, it says I'm inside the finally block. Because it did the try statement, it parsed the integer, it succeeded, it skipped over the catch, it came down to the finally, and it said inside the finally block, and then it printed out my message, 23 times 2 equals 46. If I say hello, I get a message, hello is not a valid integer, please try again, and then it says inside the finally block here. So in this case, the parseInt failed. It jumped down to the catch block, it executed the print statement in the catch block, and then it executed what's in the finally block and said inside the finally block here. So what's the weird part of what just happened? There's something a little strange in here.
Doesn't matter if it was wrong or right, it just ran it.
That's true. There's something a little weirder though. To me at least.
It's not called else? Or...
Yeah, that's a little weird. What else?
It didn't break out of the whole try.
It didn't break out when I said continue. It did not immediately go back to the top of the loop. It still printed out inside the finally block here. And so let's make this even more dramatic. Let's just, if you put in a bad number, let's just say bad input, goodbye, and just return. And we'll just, we'll give up on the user, and we won't talk to them anymore. So we'll compile that, we'll run it. That works fine. If we put in bad input, it says bad input, goodbye. But even though the next statement says return, it did not do the return as the next thing it did. The next thing it did was it jumped down here to the finally block, and it said inside the finally block here. And then it came back, and it did the return. To me, that's a little bizarre.
Does that mean it runs no matter what?
No matter what, it's going to do this finally block.
What would be the point of that? Like, would that just be kind of like a closing statement kind of a thing?
Or more like a PS in a letter.
Yeah.
Closing streams.
Yeah, it's like saying, best wishes, Nick, and then putting a PS at the end. And to me, when you see, the salutation at the end, that's the end of the letter. But it's like, oh yeah, but keep reading because there's this postscript. So it's kind of like a postscript. Personally, this bugs me. This is one of the few things about Java that really kind of like rubs me the wrong way. Because as someone writing code, when I see a return statement, I want to believe that that's where it's going to return. It's going to kick out right there. And the behavior of this language element is now contingent on stuff that happened earlier. Like the fact that this isn't a catch block. Just feels a little weird to me. But,
That'd be really useful in C, like for like free statements and things like that.
Yeah.
No matter what at the end of it, it just frees everything.
And that's what it's really for, is like, if there's something you want to do at the end of this chunk of code, regardless of whether it succeeds or fail, it lets you put it down here. But you could just call a method that does that too or something. But I guess it makes sense to someone.
Maybe you were in the middle of writing to a stream and you can't just leave it there,
Mm-hmm.
So
Right,
just
right.
Clear that or something.
Mm-hmm.
Have it like half complete or whatever.
So here's something that I just did a minute ago, and this is another sort of pet peeve of mine. So suppose we say system.exit 0. right? So if an error occurs, I'm going to say bad input, goodbye, and I'm going to exit the whole Java program, right? This will basically do the same thing that return does, but I'm just going to give up on the user. But when I try to compile that, I get an error saying n might not have been initialized. Because the compiler is looking right here and it says, hey, you know, if this parse fails, n may not have a value. And when you get down here, I may not know what to print. And so it's not going to compile my code for me. Well, I know that it's never going to get down here unless this succeeds, because if this fails, I'm going to come into my catch block, I'm going to exit my program. The compiler's not smart enough to know that. And it's refusing to compile this code because it thinks there's a possibility that when it gets here, n might not have a value. And so you're forced to initialize n to some bogus value.
That's pretty intense for a compiler. I mean, that's pretty smart to look ahead like that.
Yeah, yeah.
But also very inconvenient.
Mm-hmm.
Yeah, but C would just let you compile it and run it and just give you an error if it didn't work, and you might be chasing your tail, but this is like...
Yeah, I mean, C, you can say chop my head off and it'll do it for you. And
Yeah, this seems like very good, like easy debugging, you know what I mean?
yeah, yeah, it definitely helps. And one of the things about languages, especially throughout the 80s, a lot of languages were developed, and they were developed with this idea towards kind of trying to protect the programmer from themselves, or trying to protect the world from the programmer. Software engineering was becoming a bigger topic, and people were writing books with titles like The Mythical Man Month, and discovering that, you know, the bulk of money spent on software was not spent developing it, it was spent maintaining it. And so there was this big push towards, you know, structured programming, getting away from go-tos. And people started developing and pushing languages that would make it harder and harder to get yourself in trouble. And so you saw this kind of thing happening a lot. And in some ways that's very useful. In some ways it can be a hindrance. It depends what you're trying to do. And so a lot of languages are a balance between, you know, wanting to give you the most flexibility and control over your code while also maybe trying to save you from yourself. So we don't have pointers in Java, right? We can't use a negative subscript on an array to tinker with memory, stuff like that.
Is there an unsafe keyword here for pointers?
Oh, I don't know.
I know in C#, if you want, you can tag a block of code with a block called unsafe, and then you can manipulate raw pointers and memory addresses.
That would be cool. Yeah, I don't know what the equivalent would be in Java if it exists, but that could be useful. You can also do things like, you know, execute C code from inside a Java program. You can link in C sometimes with a native interface, and then you can do all sorts of things. And ultimately, when somebody wants a lot of speed or control out of a Java program, that's what they end up doing. So like a lot of game engines actually just link into machine language objects that were compiled from...
I had to do that once.
Yeah?
With a mod manager I was making for a game in Unity, and C# doesn't have any way to natively make symlinks. So I had to do a platform invoke to the Windows System API.
Cool. Yeah, this is where life gets fun, right? All right. So let's try catch blocks and finally blocks. For PA1B, really all you need is, you know, try integer.parseInt, catch exception E, you know, print out a message, not a legal integer, go back up to the top. You don't need anything more sophisticated than that. You don't need a finally block, and so on and so forth. All right, cautionary tale. Keep your try blocks as small as possible. If you have 1,000 lines of Java, and there's multiple places inside where exceptions could occur, you may be tempted to put your entire Java program inside one humongous try block, and then have your catch block say something went wrong, goodbye, and exit. You can do that. It's considered pretty poor style. I've just found a piece of code of mine. I had 700 lines of Java code inside one try block. It's kind of a bummer, but it was fun at the time. But you know, ideally exceptions will not occur. Usually if your code can generate exceptions, it's because there's something that could occur outside your control, or more likely you're just not doing the work to check conditions to avoid exceptions. So if I'm expecting somebody to enter a command like, you know, I space and then some number, I can check the, you know, first character of my string to see if it's an I can check the second one to see if it's a space, and so on. If my string is empty and I check string bracket 0, I'll get an exception. I get an index exception, right? So before I check string bracket 0, I should make sure the string is not empty. Well, maybe I'm in a rush, or I'm lazy, or in a mood, and so I don't bother doing that. And now every time somebody just hits enter instead of typing a command, I get an exception. Well, the right way to fix that is, you know, check the length of your string before you start trying to pick it apart. The lazy way would be just throw a try-catch block around the whole thing. And if any error occurs, just say, you know, syntax error, try again, and go back. That's fine if you're writing quick and dirty code for yourself, unless you find yourself using it like 15 years later. But don't do that for like code that you're turning in, or code you're doing, you know, for work or for a team or something. Put your try blocks right around the part of your code that could fail, and get out of the try block as soon as you're past the danger part, right? And this way, if an error occurs, you can pin down exactly this one statement, or one of these two statements is the thing that caused the error. So that's just kind of a coding project, coding habit thing. Nice. Yeah, and it kind of depends how much you're doing this by hand versus punting to some pre-existing packages. The more you're doing stuff by hand, the more conditions you might end up having to check. All right, let's talk about this business with public static void main. Actually, let's do a break first. Let's do a break. Let's come back in 4.5 minutes. All right, see you back in a few minutes. Alright, we're back. So let's talk about this main method business, public static void main. And we'll come back to this periodically throughout the term. We're not ready to completely understand what's going on, but let's just look at the most simple public static void main. And let's just print out the value of this argument args. Let's see exactly what this thing is when we run a Java program. And so if I run Java main 3, it tells me args is equal to, and it says, you know, string @ sign big long number. I should have made this a print line. So if I put some arguments after this, this is a test. It still just tells me, you know, args is equal to this thing, right? But we can believe from the way that args is declared that it's a string bracket bracket. So string bracket bracket is basically how we say this is an array. And so args is an array of strings. And so let's print out the value of args bracket 0. Since it's an array, we should be able to print the value of an element. And so args bracket 0 is this, or, you know, with a typo. So I ran this as Java main 3, and then I typed 4 words after that. This is a test, and args bracket 0 is equal to this. Well, you can guess what's going to happen here. If I print out args bracket 1, args bracket 1 is the word is. So this args array is how we can pick off command line arguments that somebody types when they run the Java program. And so if we print more of these command line arguments, we can see args 0 is this, args 1 is, args 2 is args 3 was test. And when I tried to print args 4, I threw an exception. And the exception is array index out of bounds exception : 4. And I said line 9, and line 9 of my Java program is right here. And it's telling me trying to access element 4 was out of bounds. So this args array only has elements 0, 1, 2, and 3, a total of 4 elements. So this is like the argv array in C when we declare main argc, argv. This is like the argv array. It's an array of strings, except that a string is an actual type. So it's not an array of car stars, it's an array of string. And to make an array, we don't say star, we say bracket bracket. So string bracket bracket specifies an array of strings. That's what args is. So args is an array of strings. So the question next is, how many strings do we have in this array? In other words, if we were going to print these things out in a loop, how would we do that? So there's a for loop that'll print out the first 10 arguments. And it works great, except we don't have 10 arguments, right? So how do we know the length of an array? With arrays are objects, there's a field in the array called length. And so we can say I less than args.length. And in this case, args.length will be equal to 4. And that tells us we had 1, 2, 3, 4 things on the command line. And length is not a method. It's not like string.length, which runs some code to tell you how many things you have in your string. It's a field. So it's just args.length, no parentheses. So let's print out args.length just for extra clarity. So here args.length was 4. If I add a fifth argument, args.length is 5. If I run this with no arguments, args.length is 0. Which means, again, just like in 224, if you're parsing arguments, don't try to parse args bracket 0 unless you know that the length is bigger than 0. Don't try to parse args bracket 3 unless you know that the length is at least 4. So it's exactly the same as argc, argv. Args.length is the same as argc, and args bracket I is like argv bracket I. But this is, you know, a bona fide type of a string and a bona fide array of strings, so it's a little more straightforward to use. If I say Java main 3 and then I put in an empty string, that is still an argument, because args.length is now 1 and args bracket 0 is that empty string. And this is different from this. So the way that your program interacts with the Unix environment, right, all of your 224 knowledge of Unix comes to bear. So for example, if I say double quote, this is a test, haha, guess what? Args.length is 1. It has one argument, and that one argument is this string. If I do that, args.length is 2. The first argument is this string. This is a test. The second argument is haha. This is a feature of the operating system, not Java. Right? The Java JVM is being run with this argument, and this argument. And it takes that first argument, finds a class with that name, executes the main method in that class, and then passes these arguments to it. Since it was told there were 2 arguments, this and that, that's what it passes to your main method, that's what your main picks up. So this is operating system level interaction, not Java per se. All right, and finally, if I call this haha main instead of main, I can still compile it, but I can't execute it. When I try to execute it, I get this error message, main method not found in class main3. And it even tells you in the error message how to write your main method. Please define the main method as public static void main, etc. So there's nothing wrong with calling this method haha main. It's a perfectly valid method. But when I say Java main3, here's what happens. The JVM looks in this class, main3, for a public static void main that takes string arguments. Yeah, I can make a public static void main that takes an array of strings and an integer, and that will compile Oh, except I used the same integer twice. That will compile just fine. But again, when I try to execute it, it will say, hey, I don't find a main method that I'm looking for. Please define your main method as public static void main string bracket bracket args. If I don't want any arguments, I can write a main method that looks like this, but it will compile, right, if I don't try to use args, but it won't be the main method that gets run when I say Java main3. So it's got to be string bracket bracket args as the one and only argument. It's got to be a method named main. It's got to be lowercase. It's got to return void. And it's got to be public static. So this goes back to method signatures, right? Those other main methods that we just played with, those have different signatures. So it's got to be a method with this exact signature. If I call my argument argy fargy, that compiles. Oh, but I have to change all my args. Alright, that compiles and that will execute just fine. So the name of this is not part of the signature. Right? The signature of a method is the name of the method, the types of arguments that it takes, and by extension the number of arguments that it takes. But the actual name of those arguments can be anything that you want. So signature is kind of like a function prototype. When you prototype a function, it doesn't matter what you're going to call those arguments. It matters what type of arguments they're supposed to be. So this is almost always args, and the help messages actually tell you, you know, to go ahead and define it as args. But you can actually define it as anything. But if you call it argy-wargy, people are going to wonder, which is okay. Alright, we'll talk about statics another time. Public we're going to talk about next. Void is just saying that this does not return anything. If I make this something that returns an int, it'll compile. It won't be the main method of the class, though. It won't execute when I say Java main3. Alright, questions on that? Alright, let's play around with public and private. So back to rectangles. Alright, here's my rectangle class. It does not have a whole lot going on right now. It's just holding two integers for the height and width of the rectangle. Here's my rectangle main class. So I'm going to declare a rectangle named R. And I'm going to construct this rectangle by saying R equals new rectangle. And then let's set its height. So we'll set the height to 10. And then let's check its height. And so we'll just print out r.height. And this will be the most amazing Java program any of us have ever seen. Alright, so it shows us the height is 10. Alright, not a big deal here. This is like using a structure in C. So we're constructing a rectangle, we're setting its height to 10, and then we're printing out its height. Alright, and that's you know, very kind of basic. And the rectangle class doesn't have a lot going on. Alright, so here's what we can do. Suppose you're going to construct a rectangle class, and you're going to let the person, you know, specify the height and width of the rectangle in a constructor, but you don't want them to come in and change the height by doing something like this. Okay, why might we not want someone to do that? Suppose that when you construct a rectangle, you're going to calculate ahead of time its area. So in the constructor, you're going to say, okay, area equals height times width, and you're going to save that in a variable. And when someone asks for the area, you're just going to give them the value of that area variable. Well, if someone comes in and they change the height... Whoa. Oh, we got awesome thunder going on here.
Yeah, I don't know if you saw that. I like jumped.
Alright, if I lose internet or power, just imagine what I might be saying for the next 35 minutes. And
Way further east, so I just heard it.
yeah. Alright, so let's take that as an omen. Let's do this for real. Let's make a constructor. So let's pre-compute the area. And so I'm going to have a field up here which will store the area of the rectangle. So we're going to construct the rectangle by specifying a height and a width. We're going to save the height and the width in these fields up here. And we're going to calculate the area to be h times w, or height times width. And you know, for multiplication, that's not a big operation, but maybe this is some really super expensive operation we want to do, and so we're going to compute it up here. And then I'm going to have a way to retrieve the area. So this is going to be public int area. And let me call this the area instead of area. And so my area method will just return the area of the rectangle. Alright, so now we're doing a good job here. We're going to make r.rectangle, r equals new rectangle. Let's make a 5 by 7 rectangle. Printf, there we go. Alright, so this should work pretty well. We're constructing our rectangle, and then we're going to call the area method to see what the area is. And it tells us the area of R is 35. So far, so good. Alright, now what happens if our user is, you know, super sophisticated and they know that we're storing the height of this rectangle in this variable h, and they don't want to construct a new rectangle, so they're just going to say r.height equals 1000. And now they want to know what the area of the rectangle is. Well, it tells them the area is still 35. So in some sense, they just broke our rectangle class. Now, it's really their fault because they did this and they weren't supposed to do this, but we didn't tell them they weren't supposed to do this, right? This is kind of a reasonable thing to do, set the height to 1000 and tell me what the area is. But they did not understand that instead of returning the current height times the current width, we initialized the area when we constructed the rectangle. And so this is where the implementation details of the class are colliding with the user of the class. The person who is using the rectangle class is coming in and monkeying with something in our implementation. They're modifying this field height that we did not intend them to modify. Right? Because if the height changes, we need to recalculate the value of this field, the area. So there's a broken firewall here. There's the user interface to the rectangle class. There's the implementation of the rectangle class. But the user is coming down inside the class and manipulating some of our variables inside here. And this is like, you know, in your linked list assignment from 224, if your main program comes in and starts tinkering with, you know, while temp arrow next is not equal to null. Well, that works great with the particular linked list that you implemented, but if you change the implementation of the linked list, that main program might fail. So we would like to prevent the user from doing this.
Is, in this language, if you don't give it an access modifier, does it default to public?
It defaults
Does
to
it
protected, so it's public within the package. Yeah.
In C# it defaults to private. That's interesting.
Yeah, yeah. Alright, so here's what we're going to do. We're going to take these things and we're going to make these private. And now when we try to compile our very clever main program, we're going to get a compile error and say, hey, no, you can't change the height. Height has private access. Alright, so we're kind of saving the user from themselves again, right? We're saying, hey, even if you're very clever and you understand that there's a field named height inside the rectangle object, you're not allowed to modify it. And we're doing that because if they just come in and they modify this, well, we'd need to recalculate the value of the area. And if we don't do that recalculation, this method is broken now.
It's the same deal with the hash table we made. If you went in and extended the length to 7 and you set it at a static size of 6, then you're going to run into a seg fault when you run the dump command.
Exactly, exactly. Alright, so how are we going to allow the user to interact with the rectangle? Suppose the user really wants to change the height of the rectangle to be 1,000. Well, what we're going to do is we're going to use a method. And if we write a method inside here, it has access to height and width and the area, even though these are private. They're private outside of this class. But within this class, any method can access it. We're doing that right here. So here we're going to write something which says we're going to create an accessor or sometimes a getter to let the user read the height. So we're going to make a method, and the method is going to be public. And it's going to return an int, and it's going to be called getHeight. It's not going to take any arguments. And it's going to look like this. So getHeight is an accessor, or a getter. It takes no arguments. It returns an integer. And what integer does it return? It returns the height of the rectangle. GetHeight can access this because this is private, but it's inside the rectangle class. Everything inside here has access to these private fields. So this can successfully retrieve the height and return it. And then in our main program, I wanted a mutator here. So let's go ahead and print out the height of R. Alright, so now we can see the height of the rectangle is 5, even though if we just tried to print r.height, we would get a compile error. And so let's go ahead and modify the height. And this is a mutator or a setter. and this will let the user or the caller change the height of the rectangle. So this is a public method so that the caller can get to it. It does not return anything. It's set height, and it takes an argument, which is an integer. And it just sets height equal to whatever that argument is. And so down here, instead of saying r.height equals 1000, we can say r.setHeight 1000. And that should work fine. So it compiles great. But this doesn't fix our problem that we changed the height to 1000 and it thinks the area is still 35. But we can fix that right here. Because inside our rectangle class, inside this mutator, if the height is changed to a new value, we can just repeat this calculation. The area equals h times width. And now after we've changed the height, the new area is going to be 7,000 because it's 1,000 by 7. So accessors and mutators, or getters and setters, are very common. Anytime that you have fields in a class that you want controlled access to, you can grant access through these get and set methods. And the standard naming for these is if you have an object named blah, you call the accessor get blah with an uppercase B. You call the mutator set blah with an uppercase B. So you camel case it and you put the word get or set in front of the field name. And that's very standard. And that's another thing IDEs, when you have private variables, you can go click, 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 and it'll write these methods for you. Right? Because it's always, they look exactly the same. They have a comment like this, and then they have, you know, that declaration and so on. And so this comes in with the idea of information hiding. So there's like two pillars to object-oriented code. Encapsulation, which means, you know, taking data and code and putting them together. And information hiding, which is sort of controlling what parts of an object a user can interact with and controlling in what ways they interact with it. And so having accessors and mutators is part of that.
Encapsulation, polymorphism, and inheritance.
Yeah, so polymorphism, inheritance, and extension. Yeah, so I shouldn't say the only two pillars. Depends on your school of philosophy. Is it possible to do private int x curly bracket public get set to auto set getters and setters with different access permissions? I'm not sure how much you can mix those permissions. There's some kind of precedence rule. If you're in a private function, I don't know if you can grant public access to things inside there, for example.
That actually generates the getters and setters. So you can have a public get method
Okay.
and a public set method generated.
Okay.
I don't know if you can do the same thing in Java.
I haven't seen that, but that's pretty slick.
C#.
Yeah. Well, it came after Java, so you know they get to like do the good stuff.
It's a really cool language.
Do you know why it's called C#?
It's supposed to be like C and a mix of C++ as well.
Yeah, so the story I heard, I don't know if it's true, but you know, here's C++, and this is supposed to be C+++++. I don't know if that's bogus or not, but it's a good, you know, story.
I always heard it was like a musical thing. It's like supposed to be in between the two of them at the same time.
Oh, cool. And calling it D flat just wouldn't have cut it. That's cool. I wonder what the actual story is. All right, so that's something that we'll move towards using now. Now again, you know, if you're writing code for yourself, you know, a lot of people don't bother commenting their code. They don't bother indenting their code. They call their variables A, B, C. And that's okay, right? I like to encourage people, even when you're writing code for yourself, try to use the habits that you'd like to develop for when you're writing code for other people. Um, but it's personal preference, right? Um, for me, it's very rare that I specify public or private, unless it's required. Like my static void main has to be public, um, but my toString has to be public. But mostly I'm writing, creating classes for my own use, and protected, which is the default, works fine. Um, but you can specify this explicitly to have a fair amount of control over how these methods and fields and classes are used. So public just basically says anybody can access this. Private restricts access to within this class, and there's something in between called protected. And protected basically works for a package, and a package is a concept we'll talk about later. But it's a way to have a collection of classes that are all kind of bundled together, and you can grant basically public access to other things within that package, but restrict access to anything outside. And that's actually the default if you don't specify public or private. And if you look through documentation, for example, all of these methods, right, they're public. They wouldn't be documented if they weren't, probably. And some of them say static integer, some of them just say byte without the static keyword. We'll talk. Whoa. It is hailing severely. Wow.
Yeah, we're getting some crazy snow on the east side right now.
Really? Okay.
Hawkinson area.
Yeah, this is intense. Maybe I shouldn't be talking heresy about.
By my window.
Yeah.
I can't have it open.
Yeah, this is the craziest hail I've seen. How many people had trees down yesterday?
Yeah, we have a private driveway that's really long,
Mm-hmm.
and we couldn't even get out. We had to cut a bunch of trees up yesterday.
Okay, yeah.
Because everything had fallen across our road.
Yeah, we went out for a walk. We were just pulling trees out of the road on the way.
There was a bunch down in Lackanis Park where I usually do my daily lunchtime walk.
Okay. Yeah, pretty intense. Let's see. Oh, well, good thing you weren't on the balcony. All right, so questions about this? Let me take a moment of class time. I have a question from someone on an ODP. So I have to leave exactly at 3:10 because I have an appointment at 3:15 on Wednesdays. But let me take a look at someone's. Assess. Let's see. So, okay, ODP 301. So, ODP 301, you're creating this class called myClass. it should save the argument to the constructor in a public variable named x. And so you don't want to create a method named x. We're not creating an accessor here, right? You're just dropping this into a variable, just an integer x, and that's all your class does. And then your main program, for example, if it wants to read the value of x, it uses the name of the object .x. And so, question I got in private chat, take a look at that. Don't write a method named x. Just make your integer named x and copy your constructor's argument into that. And then it should assess fine. Alright, we got, I guess it's full on snow now.
No, it's hail. That's the thickest hail I've
Is
ever
that
seen.
still hail?
Yeah.
Wow. Cool. All right, and yeah, I just addressed that, and try what I described. All right, other questions? Alright, so where do we go from here? You should be able to finish up PA1B over the next few days. And programming assignment 2 I'll talk about on Monday, and you're going to have 2 weeks for that. So I'll post that out on Monday. I'll post another ODP tomorrow, which will involve accessors and mutators. And it's another version of ODP 301, except instead of just hitting the variable x as a field, you'll have to write a setter and a getter for it. And so what I want to do next time, maybe we'll start this today, is look at if we wanted to construct, say, our own linked list class in Java from the ground up without using the linked list class that's available to us, what would that look like? And so I want to look at doing the kinds of things we did in 222, declaring a node and having, you know, a data field and a next field and linking these nodes together in a chain and seeing how we do that from Java. And it's a fair bit more straightforward than it was in C. And we may end up doing some of that in PA2, and we'll definitely do that in one of the later PAs when we start creating decision trees, which are a different type of binary tree. We'll construct those by hand. But so that's coming up, and I want to play with generics, and generics will come into that. We'll create a linked list class, and then we'll modify it so that it will work with integers or strings or different types of objects, and we'll make it generic so you can specify in angle brackets what kind of things you want to put in your linked list. Yeah, go ahead.
Damn, that was some loud thunder.
Yeah. And it was like pouring snow a minute ago, and now it's tapered off.
I wonder if you guys are further to the west and are going to hear that in like 10 seconds.
Possibly, yeah. So I'm like at the northern part of Lacamas Lake.
Me too.
Okay. Yeah, this is just rolling thunder. All right, well let's just take a start on this. And maybe I'll end class 5 minutes early and give myself a few minutes. But let's just go back to 222 and this idea of a linked list. And you know, we had these nodes, and these nodes typically had two fields, a data field and a next field. And the idea is you plop some, you know, for example, an integer in here, and then this somehow refers to the next node. And And so instead of a structure statement, right, we would declare a node to be a class. So we could say class node. And let's go ahead with integer for our data type. And then what is our next field? Well, that's just another node. And so there's the two fields that make up our linked list node. And that's pretty much all you need. And then we could make a class called a list. And this is our linked list. And if we're going to have a sentinel node, and sentinels are handy, we could have a sentinel node. Well, how would we declare that? We would just say we have a node called sentinel. And then in the constructor, we could construct a node and set sentinel equal to it. So our constructor might look something like this. Public list. And this would say sentinel equals new node. And then we could say sentinel.next equals null. And now we've got, the beginnings of a linked list class. So in our main program, we construct an object of type list. And as soon as we construct the list, right, this constructor gets called. It creates a node, right, one of these things. It sets the next field to null. It sets this kind of global variable called sentinel equal to that new node. And then I could write something like, public void add integer n. And if I wanted to add in the beginning of the list, let's do the first version of the linked list that we did from before. So how do I add to the beginning of the list? Well, I could do, node temp equals new node. Temp.data equals n. Temp.next equals sentinel.next. And then sentinel equals temp. So what does this do? It creates a new block. It sets the data field equal to whatever I pass to my add method. It makes that new block point to whatever the sentinel is pointing to, and if it's null, it points to null. If it's a block, it points to that block, and then changes my sentinel to point to this new node. And so this 3 or 4 line method, creates a new block, puts it in the beginning of the linked list. So now the sentinel points to my new block, and that block points to wherever the sentinel pointed. And you can just, build this up the same way we did in 222 with C. And as you're developing these classes and you're using them, you start to develop preferences. And for example, every time that I create a node, right, I need to set the data value to something. And I need to set the temp value to something. A lot of times I'm going to set the temp value, the next value equal to null. And so I might actually create a constructor in my node class. And the constructor would take an argument that's an integer, save that integer in the data field, set the next field equal to null. And now my node temp would just be new node parentheses n. I don't have to do this. Or I could specify, the value in the constructor for the data field and the next field. And then my add method would be a one-liner. It would just say sentinel equals new node parentheses n comma sentinel.next.
Are we going to talk about operator overloading maybe in this one. So like when you want to index the list, but you can do with bracket syntax.
No, there's not a whole lot of operator overloading in Java.
Oh, okay.
Yeah, that's a nice feature in some other languages. But the idea for people who don't know is in some languages, for example in C++, you can make a function and you can name that function effectively something like star. And so if you have two rectangles and you say rectangle star rectangle, it'll actually call a method that you've created that you said should be called when I use this operator. And it doesn't buy you anything except it makes your code look a lot more natural. So if you really think about multiplying rectangles, you can use the same multiply symbol that you've always used instead of having to say, you know, multiply rectangle, comma rectangle. And so that's something called operator overloading. And if you are extending your data types to include fractions or complex numbers or whatever, then it's really nice to be able to just treat them the same way you do other similar data types. All right, so we'll do this in gory detail on Thursday, and really think about sort of how to design the different classes that would go into something like a linked list class, and we'll go through different versions of this and kind of build it up methodically. I will let you out 5 minutes early today unless there's any other questions, and one person pinged me asking about some help after class, so I'll stick around for a few minutes. If you want to screen share, go ahead and do that. Otherwise, you're good to go. Have a good afternoon, enjoy the snow, and I will see everybody on Thursday.
Thank you.
Thanks.
Have a great day.
You too.